everyone. Welcome to Ask IITians Learning. My name is Bhavya and today we are going to discuss the third chapter of grade 9, which is atoms and molecules. So, in this chapter, we'll be learning a lot about things like what exactly is an atom, what is a molecule, how do they combine, what are their masses, when they combine, how do they do so, and why do they combine? So all these questions we will be giving an answer to in this very chapter. Along with that, because these are general terms which you have already heard, right? But there is a term which you might not have heard, and that is moles. So in this very chapter, in the further classes, we would be also discussing about what exactly are moles and how are moles formed. What is the significance of it and how to use that information in our day-to-day life. So those things, of course, we will be discussing. But first, let's talk about the topics which we are going to cover in today's class. So in today's class, we would be first knowing about this chapter, and then we would be discussing about further some laws like the law of chemical combination, the law of conservation of mass, constant proportion, etc. So let's get started. Okay. So when we talk about the part or the thing known as atoms and molecules, so what do we understand by it? Okay. Now, when we talk about atoms and molecules, the very first thing which we see around us is matter. You all have heard about it, right? From the very smaller classes, you've been knowing that everything around you is composed of matter. What exactly is matter? Matter is anything which occupies space and has mass. Anything which occupies space and has mass. So whatever you see around you, table, chair, fan, clothes, utensils, laptop, phone, charger, table, pen, anything you see, everything is made up of matter, or rather I should say everything is matter, right? Everything is matter, even humans. Now, when we talk about this matter, so the question that comes to any curious mind is that, okay, we understand that everything we can see and we can't see, like air. I cannot see that, but of course I can feel its presence. So everything that we can see or we can't see is made up of matter. But then, what is matter made up of? So matter is made up of extremely tiny particles known as atoms. Extremely tiny particles known as atoms. So this is what matter is made up of. So you talk about a very slightest thing like any sand particle, or very tiny sand particles, to black holes and wormholes. Whatever you think of this universe is composed of, everything is matter, as per now. Though, just FYI, there are things which are known as dark matter, antimatter, and so on. But these things are in their stages of technological advancement and discoveries. So since we have not exactly found out anything with proper proofs, so we just consider it as a part of learning and not as a part of existence as of now. Let's talk about matter. That was just an additional information. So matter is made up of atoms. Now, basically, when we talk about previous people, okay, so nowadays what we know as chemistry, previously that was alchemy. Previously, chemistry was basically alchemy. Now, what exactly is alchemy? Or you might have heard about alchemists. So basically, what happens is, like, nowadays we have a lot of technological advancements. We have equipments, we have machineries, we have scientific technologies by virtue of which we can do experiments and prove things, right? But previously, people had that mind of thinking deep into the very roots of nature, but they do not have a proper evidence to support what they thought, right? For instance, suppose you are playing a game, okay? You might have a strategy. You might have a strategy that if I roll the dice this way, definitely this number will come. But that is in your head until and unless you prove it. So there has been no experiment. Without proof, science is not valid. Science is just like law. You need proofs for it. And those proofs are basically experiments. But does that mean that you do not have a curious mind or you could not have thought that way? Of course, that doesn't mean that. It means you do have a scientist mind, a scientific evaluation technique in your head. But because of lack of advancement, you could not prove it, right? So at that time, in the earlier era, people had that thought process. And those people were not known as scientists, they were known as philosophers. Earlier, people were known as philosophers, the ones who had curious minds, the ones who were sharp, who were brilliant, who knew the things but could not prove that. So those were philosophers. Now, there were many philosophers in that early stage. One of a very special and very known philosopher was Maharishi Kannad. Maharishi Kannad. So, he was an Indian guru or Indian scientist. He said that everything which is there in nature is composed of small particles known as anu. Anu, as in minute particles. Okay. Now, later on, there were further advancements, and there were many scientists like Democritus. So, Democritus was again a philosopher of the medieval countries. So, he also said a similar thing, but it was Mr. John Dalton, who was a scientist who proved that matter is composed of extremely small particles called as atoms. And he called them, because the earlier language was Latin, so he called it as atomos. Atomos, meaning indivisible. It means indivisible, right? So this was done by the scientists of that era, that this smallest particle is known as atomos. So now we talk about the next thing about these atoms and molecules, and that is how to identify or how to know that yes, a substance is made up of a small particle. So for that, we'll do a very small experiment or very small work. Suppose you have a wooden log, or suppose you have a wall. Anything like you have a wall or you have a wooden log, something which is big. Or An easier thing will be chocolate. So what if you have a bar of chocolate, right? You have a chocolate bar. Now you break it into pieces. Now you will get equal subdivisions. Okay. Now you took another piece and you further break it. Right. Now you take further and break it. You take further, break it. Further, break it. Break it. So you keep on breaking it, right? When you keep on doing so, you might get or land up to a very small particle which still is visible. So you know that yes, you have broken it into something. But when you keep on doing it at an advanced level, okay, you will see that it keeps on breaking into a very, very small particle, a very small particle. And that small particle is known as atom. That very small particle is known as atom. You remember that we have done this in our very first chapter also. In our first chapter, when we discussed about the properties of matter. So yes, it was made up of an extremely small particle known as atoms. Now, when you talk about these atoms and molecules, as we have discussed, it is present in our every day-to-day life. Be it crayons, be it candies, the things we eat, the things we wear, the things we see, the things we play with, whatever you see around you, everything is made up of matter and atoms, right? Now, as we have discussed that the first scientist who gave a scientific discovery and experimental proof of things was Mr. John Dalton. Now, when he discovered about atoms, he gave further some points about his discovery. Those are known as the postulates of his very theory, which is known as atomic theory. So Mr. Dalton gave his famous atomic theory, and this theory had varied postulates. The first postulate is that matter is composed of very small tiny particles called atoms, and these atoms are indivisible in nature. This was said by Mr. Dalton. Then he said that they're so small to see that you cannot see it with your naked eyes. And for that, you need a microscope, which is like electron microscope or a very strong microscope to see the atomic levels. These atoms cannot be created or destroyed in any chemical reaction. So whenever you're talking about a chemical reaction about which we are going to discuss in a while, you cannot create them or destroy them. Then he said that atoms of specified element, if you talk about a very specific element, then its atoms will be identical in mass and properties. Whereas if you talk about atoms of different elements, like if you talk about same element, for instance, nitrogen or oxygen or hydrogen, so all hydrogen atoms will be identical in mass and identical in properties. Whereas if you talk about different elements like nitrogen and oxygen, sulfur and hydrogen, so they will have different masses and different properties. Then he said that atoms will combine in the ratio of small whole numbers to form compounds. Atoms combine in small whole number ratios like water. So if you talk about water, hydrogen atoms are 2, oxygen atom is 1. So yes, they are combining in small whole number ratios. Water, CO2, NO2, N2O, carbon monoxide, sulfuric acid, whatever you talk. So they have a simple whole number ratio. So that also makes sense. Then he said the relative number and kinds of atoms are constant in a given compound. So if you talk about a particular compound like water, so in water, the relative number and the kinds of atoms. So kinds of atom are hydrogen and oxygen, and their number is 2 hydrogen atoms, 1 oxygen atom. So that number and the kind of atoms remain constant in a given compound. Now that also makes sense. So this was his theory, which looks good, but actually it is faulty. No matter how good looking it is, it's literally faulty. Now, of course, that faulty nature we didn't know initially. Had Mr. Dalton been knowing about it, he would have definitely corrected it. But he didn't know. And how could he know? Because there was more technological advancement which was yet to happen. And it is because of that that we found there had been so many different things and so many experimental findings because of which his theory was proved wrong. But since it was the first theory of its kind, or the first markation towards a new science, that we give extreme respect to Mr. Dalton, and we still talk about his theory. Right? For instance, how can we say that he was wrong? Now, he's right that matter is composed of small tiny particles called atoms, but he was wrong when he said it is indivisible in nature. Because we know that atoms can further be divided into smaller fundamental particles known as electrons, protons, and neutrons. So atoms can further be divided into electrons, which are negatively charged, protons, which are positively charged particles, and neutrons, which are chargeless species. In fact, these are not all. Just for your information, these are not all. So do you know that we do have other specific particles like neutrinos, antineutrino, and quark, etc. So you have mesobosons, mesons. So there are many particles which are there, multiple particles, out of which the famous three are electrons, protons, and neutrons. So this portion is wrong. This was wrong. Now, of course, these are very small to see with the naked eyes, and they cannot be created or destroyed in a chemical reaction. Now, again, this part has a glitch. Yes, we can do so. And that is possible in nuclear reactions, about which we'll be studying later in higher grades. Nuclear reactions. These are the kinds of reactions which are occurring on sun, nuclear fissions and fusions. So that's again a part which was further proven wrong. Now I said that atoms of the same element are identical in mass. Now, by looking at this statement, it feels correct. It actually feels correct because we think that yes, if the atom is of the same type, of the same element, then of course it has to be identical. But no. You will eventually learn in these classes a thing called isotopes. So isotopes are the elements having the same atomic number but different mass numbers. It means that if I talk about hydrogen, so we have the same variant of hydrogen, which is known as deuterium, okay? But But in this deuterium, the mass is double that of hydrogen atom. So the mass of hydrogen is 1 and the mass of deuterium is 2. And there is another isotope of hydrogen. Again, it is hydrogen type, known as tritium or tritium. And this is having an atomic mass of 3. It is 3 times heavier as compared to a regular hydrogen atom. This is unique, right? We'll be discussing about these things in great details eventually in our chapters. So don't worry about it, right? Now, again, we talk about atoms of different elements have different masses. Again, that makes sense because if you have two different elements, we can expect them to have different properties. But again, we have another thing called isobars. What are isobars? Isobars are atoms having same atomic mass but different atomic numbers. So see, atomic number is the thing which defines an atom. So if the two atoms have the same atomic number, it means they are same element. If they have different atomic numbers, they have different elements. Technically, atomic number is about the total number of protons present in an atom. And we will be discussing about it in this very chapter under the category of ions. There we will be discussing about it. Now, what are isobars? So there are two atoms which are different, but by chance they are having the same mass. Those kind of species are known as isobars. For instance, we have argon and calcium. Now, argon and calcium, they both are different elements, but they both have the same mass, which is 40. They both have same mass, which is 40. All right. Are we clear up till here? Yes, that's good to know. So now we come to the next point, that atoms combine in the ratio of small whole numbers to form compounds. Makes sense? Whenever the two atoms combine together, they are combining so in a simple whole number ratio. But of course, as we know, we are talking about the limitations or the drawback of this theory. So in this, we realize that we have something which is known as the non-stoichiometric compounds. The non-stoichiometric compounds. Okay. Now what happens in these? These are a very different class of compounds about which you will be doing and studying in grade 12. But I will give you a hint of how these compounds looks like. See this. Doesn't it look different? So here, the ratio is not a small, a simple whole number ratio. It's not like 1:1 or 1:2. Ni stands for nickel, O stands for oxygen. So nickel and oxygen are not in that 1:1 ratio or 2:1 ratio or something, a simple whole number. It is 0.98:1 ratio. These kind of compounds are known as non-stoichiometric compounds, which further disprove Dalton's theory. Next is the relative number and the kinds of atom are constant in a given compound. Okay, which is wrong. Why wrong? Because if I talk about water, indeed, we talk about water. So water has 2 hydrogen atoms, 1 oxygen. So relative number, okay. What about kinds of atom? Now, don't you think that if I replace hydrogen with deuterium, even that is water? Because we know that hydrogen and deuterium, they are isotopes. It's just that the mass of deuterium is 2 times that of hydrogen. It is twice. And therefore, we call this water, which is your deuterated water, as heavy water. We call it as heavy water. So by this, we can say that yes, relative number is all right, but then kinds of atom, not same. Both are water, but they have different atoms present in it, right? So no matter how good this theory looks like, you see almost every point has an exception, every single point. But I would say that this theory is wrong in itself because, see, there have been many things which were many postulates which were responsible to find out further laws of chemical combination. For instance, if I say this part, if I talk about this very part, right? So as per this part, we could find or we could get the law of conservation of mass, which is one of the law of chemical combination, law of conservation of mass, which is coming directly from this postulate. Another postulate, this one. This is responsible for another law of chemical combination, that is law of constant or definite proportion. Law of definite proportion. I hope things are clear up till here. Yes? Shall we move ahead then? Great. All right. So now let's come to the chemical combination part. Now, what exactly happens? You know that whenever the term chemistry comes to your head, the things which come to your head are the chemical reactions which are occurring around you, right? For instance, you have seen that when you keep an apple, when you cut an apple and you keep it, okay, and suppose you cut your apple, you kept it on your study table thinking that you'll be eating it after some time, but you forget. What happens? It becomes reddish in color, right? So that happens because of oxidation. That entire thing happens because of oxidation, which is a chemical reaction. Another thing, you keep milk, okay? Suppose you have left milk just like that for 3 days. Okay, so what you'll realize is that that milk will become sour in taste. Okay, it becomes curd. It has a curdy-like appearance. So that's again because of chemical reaction. You've seen a small seed ripening into fruit and tree. Again, a chemical reaction. So there are a lot of chemical reactions which are occurring around you, right? Basically, what exactly is a chemical reaction? It is a way of denoting the interaction of 2 or more molecules. It is just a way of depicting the interaction between 2 or more molecules. So in a chemical reaction, basically 2 or more molecules interact together to produce new compounds with different properties, completely different properties. And in these compounds, or when you talk about the product formation or in these chemical reactions, what happens is we generally observe some kind of change. Okay, generally, not always. Some changes like precipitation might happen, or heat production might happen, or a color change might happen, right? So basically, these two or more products, which are two or more molecules which are reacting. So we show them this way. Like if I talk about hydrogen. So you know that hydrogen is a molecule, right? Now this hydrogen molecule can react with oxygen, right? And what does it produce? It produces water, in which there are two hydrogens and one oxygen. So completely different products are obtained. So whenever we talk about any chemical reaction, there are different molecules which are reacting and different product which is obtained. The reacting species are known as reactants. The reacting species are known as reactants, and the substance so formed during the chemical reaction is known as a product. So reactants give you product, and the reaction is and the way by which we depict it is known as a chemical reaction. Right? I hope this part is clear up till here. Yes, good to know that. So now let's proceed further. All right, so now we talk about the next thing, and that is how a chemical reaction actually takes place. So see, the very first part is a change in color. So this reaction talks about a change in color whenever there is a chemical reaction happening. This one is precipitation. A precipitate is being formed. What is a precipitate? Precipitate is basically an insoluble compound. If you'll see here, this part right now, here, initially this was a general liquid, right? A pure transparent liquid. But after the reaction, there is this insoluble substance which is formed. And that insoluble substance will after some time settle down. And this settling down of this insoluble substance is known as precipitation reaction. Over here, if you'll see, this is evolution of a gas and leading to a heat change, completely different change in temperature. This is how we generally identify any chemical reaction. Now, whenever these chemical reactions are happening, they always do so with the help of some combination or some particular laws. Whenever a chemical reaction is to take place, it eventually happens using the varied laws of nature. And those laws of nature which are used during a chemical reaction are known as the law of chemical combinations. So in these laws, we have multiple such laws. Okay. The very first being the law of conservation of mass, about which we had a small discussion before also. Now, as the name suggests, conservation of mass. So basically, in this chemical reaction, we are conserving the overall mass in a chemical reaction. So what do we do? Here, what we say is that matter cannot be created nor destroyed in any chemical reaction. It means that whenever a reaction happens, so you have some reactants giving you products during any chemical reaction, right? Now you can have n number of reactants. You can have different reactants. Right? And you will get a different product. Right? Now, whenever you talk about this sort of reaction where the particles will be different for reactants and the particles are different from products, so the different reactants giving you a different product, overall, they should have same mass. It means the total mass of reactants is equal to the total mass of products. Total mass of the reactants is equal to the total mass of products. This is also the very laying foundation for balancing of chemical reaction, which you will be studying eventually in the classes. And there's the first chapter of grade 10 completely devoted on this. So balancing of chemical reactions is based on the law of conservation of mass. For instance, suppose I'll just highlight this part as red for your simplicity's sake. Okay. And I'll just highlight this part. Can you see this part? Now here, this is hydrogen. This is nitrogen. And this is NH3, ammonia. So nitrogen and hydrogen together produce ammonia. Now, just for your information, the mass, if you talk about the atomic mass of hydrogen, as I said that we will be discussing about the actual values and how to remember these values eventually in this chapter. But right now, I'll just use that information. Okay. So I'll just use the information that the mass of hydrogen is 1 and the mass of nitrogen is 40. Okay. This is the mass of atom. So the mass of hydrogen atom is 1. The mass of nitrogen atom is 40. Okay. Now tell me, if I talk about hydrogen as a molecule, so in a molecule, you have 2 or more atoms combined together. A molecule means a substance or a species in which 2 or more atoms combine together. Now, these 2 or more atoms could be same or different. They could be of the same type or different type. So here tell me, if in hydrogen molecule, I have 2 hydrogen atoms. So what will be the total mass of hydrogen molecule? 1 hydrogen means 1 mass. Second hydrogen also means 1 mass. Together it would be correct. 2. Right? Now, what about nitrogen? What about nitrogen? So 1 nitrogen atom 14, second nitrogen atom also 14. So the total mass will be correct, 28. So on the left hand side, you are getting a total mass of 30. On my right, for ammonia, there is one nitrogen atom which is having a mass of 14 and 3 hydrogen which is having a mass of 3. So total mass is 17. Now, as per law of conservation of mass, total mass of reactants has to be equal to the total mass of products. But I know 30 is not equal to 70. So it means this way, the reaction is not at all following the law of conservation of mass, right? So what should I do? I need to balance this reaction. Balance as a whatever are the relative number and the types of atoms, they should be same on both the sides. LHS has to be equal to the RHS. Now if you'll see, on my left, hydrogens are 2, right? There are 2 hydrogens here, whereas there are 3 hydrogens here, right? So what will I do? I'll take the LCM of 2 and 3, which is 6. So in order to get 6, what do I have to do? I have to multiply the left-hand side by 3 and the right-hand side by 2 to get the LCM same. Which means that now I have how many hydrogen molecules? I will have 3 hydrogen molecules. Right? Now, in ammonia, since once ammonia has been formed, I cannot change the formula of it. So basically, what should I do in order to make it 6? I'll take 2 molecules. I'll rather take 2 molecules of ammonia to get 6 as the value. Right? So in order to get 3 more hydrogens, I'll use this way, another 3 hydrogens. Right? So here also I have 6 atoms of hydrogen. Here again I have 3. Now there were 2 nitrogens on my left and only 1 on my right. So again I'll take the LCM. I'll multiply this with 2. I'll multiply this with 1. So again I cannot change this. So what I'll do is I'll take another molecule of ammonia itself. Right? And now, if I talk about the balanced equation, so the balanced equation will be 3 molecules of hydrogen plus 1 molecule of nitrogen is giving me 2 molecules of ammonia. Now the reaction is balanced. Mass, there has been a conservation of atoms, same number and types of atoms on the left hand side and the right hand side. Now I'll check for masses. So now if I look, 1 hydrogen means 1 mass. Now how many hydrogens am I having? So 1 molecule of H2 will have a mass of 2. So 3 molecules will have simple unitary method, 3 into 2, 6. Nitrogen will have a mass of 14, right? So that is the mass of 1 nitrogen atom. So I have a nitrogen molecule. So the total mass is 28. Now, ammonia, previously we calculated the mass is 17. But this time I'm having 2 ammonia particles. So it is 17 plus 17, which is the mass of products. Are the 2 masses same? Yes. So this time the masses are same. It means that this equation is following law of conservation of mass. Total mass remains same, right? total mass remains same. Before and after the reaction. Total mass remains same before and after the reaction. Done? Got it? Up till here? Good. So now let's talk about another thing which is known as the law of constant proportion. Now in the law of constant proportion, what does it say? It says that a pure chemical compound contains the same elements combined together in a fixed proportion by mass. And this is given by the law of definite proportion. Now, here, a pure chemical compound contains the same elements combined together in fixed proportion by mass. For instance, I talk about water. So this is a pure chemical compound as per the definition, contains the same elements. Elements are hydrogen and oxygen together in a fixed proportion by mass. So what is the mass of hydrogen? So since there are two atoms, the mass of hydrogen will be 2. Since one oxygen atom is there, the mass of oxygen will be 60. So hydrogen is to oxygen is what? 1:8. This is the fixed proportion by mass. This is the very definition of law of constant proportion. Right? So same way, can you quickly tell me, if I take carbon dioxide, then what will be its mass ratio? Quickly do. The mass of carbon is 12. So right. Mass of carbon is 12. So here, since it is CO2, so oxygen's total mass is 32 and not 16. Right. So here, what will we do now? Because there are 2 oxygen atoms. So now the ratio will be what? 3:8. Got it? This is the ratio 3:8. Everyone received it? Understood it? Right? Now, as we have discussed before, these laws were derived from the Dalton's atomic theory, right? Since the atomic theory has glitches and there were limitations, so it means even in these laws there are limitations, right? So when I talk about the law of conservation of mass, what is its limitation? Its limitation will be nuclear reactions, as we have discussed. So its limitation will be nuclear reactions. Just like we had for previous time. Now, in the nuclear reactions, you might be doing it in physics later. So in physics, there is a Einstein's equation, which is E equal to mc square. So basically what happens is during a nuclear reaction, mass gets converted into energy. So basically an atom is completely collapsed. So that thing you can imagine using bombs. Have you seen bombs, at least in movies? Yeah. Of course, I know that you don't belong to any such group which will carry bomb in their day-to-day life. So yeah. When you talk about bombs, okay, you might have seen it in movies. So you have seen that there is a small round part, or you might have burnt crackers, right, on Diwali or New Year, right? So when you burn crackers, okay, particularly the bombs part, so what happens? There's a bigger mass, right? Now, when you burn it, what happens? It gets completely exploded, right? Shattered into smaller pieces, okay? And basically, that big part of the cracker, suppose you talk about a bomb as in a cracker, okay? So when you use it, it gets exploded into particles, right? It gives you light, it gets exploded, and you get smaller particles present in your on your floor after burning, smaller particles. But as compared to this, it has a different mass, right? Whereas this was your reactant, let's say it has x mass, or its mass was x grams, right? Let's say its mass is x grams because it was big in size. Now, when it exploded and shattered into smaller pieces, so smaller fragments, its mass was smaller this time. Let's say it is y grams, and we know that x is greater than y. So the question comes, where has the remaining mass gone? Because we talk about law of conservation of mass. So where is the remaining mass? So that mass gets converted into energy. You have seen that these crackers will give you amazing lights and noise, right? So noise is a type of energy, light is a form of energy. So basically, it gets converted into energy. So that equation is given by Mr. Einstein. Okay. Mr. Einstein. So this is your Einstein's equation, which is E is equals to mc square. So this tells you about energy and mass relation, that basically it is the mass which gets converted into energy or vice versa. This is possible. It means not every reaction, like here, it is not following law of conservation of mass, a limitation. Right? Same way, if we talk about the law of constant proportion, again, there is a limitation, as we have already discussed. So the limitation will be presence of isotopes. For instance, if you have normal water and deuterated water, heavy water. So here, hydrogen is to oxygen ratio is 1:8, as we have calculated before. Now, deuterium can also be written as 2H, because deuterium is also written as this one. This is the way. So this is just signifying that the mass of deuterium is twice that the mass of hydrogen. So here, the ratio of hydrogen is to oxygen is what? Since this time, the mass of hydrogen, the mass of one hydrogen atom is 2, right? The mass of one hydrogen atom is 2. So there are 2 such hydrogens. So their total mass is 4. What is the mass of oxygen? 16. So the ratio will become 1:4. So even when the compound is the same, the elements combining together are the same, elements are same, both are hydrogens, then even then it is not happening with a fixed proportion mass. Previously it happened with 1:8 ratio, now it is happening at 1:4 ratio. But all these things that we are doing, this is extra. these limitations which we are discussing is actually extra. This is not a part of your NCERT. Okay, this is for extra Olympiad level that we need to understand. What if they twist a question? So this is what we are doing just for your Olympiads, right? And technically, these all things will come again in your first chapter of grade 11, that is some basic concepts of chemistry. So you will be learning about everything again. I hope it's clear up till here. Anyone having any doubt, please ask. So if in case you have any more doubt, you can always ask it on forum or on our YouTube channel. You can put your doubts over there and we will definitely discuss that, right? And now let's move to some questions. All right. So let's see our very first question. If you have understood everything, I'm pretty sure you'll be able to give an answer. So the question says, in a reaction, 5.3 grams of sodium carbonate reacted with 6 grams of acetic acid. Okay. The products were 2.2 grams of carbon dioxide, 0.9 grams of water, and 8.2 grams of sodium acetate. Show that these observations are in agreement with the law of conservation of mass. Now, as per the given information, even if you do not know the reactions or you do not know the formulas, you know the thing that he said that this is reacting with this. It means these two are my reactants, right? When they are combining together, they are giving you different products like carbon dioxide, sodium acetate, and water. Right? Now, if I have to prove that this is an agreement with the law of conservation of mass, what do I have to do? I have to keep their masses and see whether the mass of the reactant is equal to the total mass of the products or not. So let's see that. After writing the reaction, I'll just put their masses here. I'll see that LHS is equal to what? 6 plus 5.3, that is 11.3 grams. Same way, I'll put RHS together. 8.2 plus 2.2 is 10.4. 10.4 plus 0.9 will again give you 11.3 grams. So since my LHS is equal to RHS, it means that the total mass has remained conserved. There was no loss of mass. Mass of reactant is equal to mass of product. This definitely proves law of conservation of mass, right? Clear? Great. So let's do another question. Now this question says that hydrogen and oxygen combine in the ratio of 1:8 by mass to form water. This thing we just proved, right? What mass of oxygen gas would be required to react completely with 3 grams of hydrogen gas? Now, whenever we see this kind of question, we know that we have to use unitary method, just like you have mathematics. Simple maths. That if during a birthday party, I give two candies to each child, then if I have 20 children, how many candies do I need? It's exactly that sort of question. Yes, isn't it? It is, right? So what happens? Now we know that hydrogen and oxygen mix in the ratio of 1:8. Oh, please correct this. This is oxygen. So we know that hydrogen and oxygen mix in the ratio 1:8. Right? It means that for every 1 gram of hydrogen, we need 8 grams of oxygen. Right? So now if we have 3 grams of hydrogen, how much oxygen would I need? So if one needs 8, so if one child gets 8 candies, so 3 children will get 3 into 8, 24 candies. Basically, for 3 grams of hydrogen, I would be needing 24 grams of oxygen. That will be my answer. Got it? Yes? That's wonderful. So that is all for today's session. Now we'll be moving ahead and we'll be discussing about the remaining laws in our next session. So stay connected and keep learning from Ask IITians. Bye-bye.